All right, let's try using the distance formula in an example. So example 7, they give us 2 points, A and B. All right, and we need to take those points and plug them into our distance formula. So I'll label my x1, y1, x2, and y2. All right, so when I plug in to the distance formula, it's going to give me the length of AB, so I'm going to write it as AB. Remember, this means the length of AB equals the square root. I'm going to do parentheses, x2, -7, minus x1, -5. Now, we have minus -5, so that's going to become a plus 5. Anytime you have minus a negative, it becomes plus a positive. So -7 plus 5 squared, don't forget the squared, plus y2 minus y1, -8, minus -2 becomes a plus +2 squared. All right, now let's solve it. -7 plus 5 is -2 squared, and -8 plus 2 is -6 squared. Now, notice I kept the parentheses here, and it's going to be important to do this when this is a negative number. All right, because if you try and, on a calculator, type -2 squared, it's going to tell you that it's -4. But if you type it with parentheses, it'll tell you that it's +4. Okay, and so it's really important that you use these parentheses when you're squaring a negative number, because this is correct. This is what we want. It's just the calculator thinks you're doing 2 squared and then making it negative afterward. But really, we want to do -2 squared. All right, so make sure you put parentheses when it's a negative. So -2 squared is +4. It should always be positive anytime you square a number. And -6 squared is +36. Add those up, you get 40. So the square root of 40. Now, again, we're not using calculators. So we need a way of turning this into a final answer. And it's a way you should have learned in Algebra 1 that I'm going to go over again. And my way might be slightly different than the way you learned in Algebra 1, but use whatever way works for you. All right, but we have to simplify this. You have to simplify your square roots. Okay, because we can't write it as a decimal because we don't have a calculator. Now, if it's just a perfect square and you can just take the square root, then great. You can just do that. But if it's not a perfect square, you have to simplify it. So here's how we do that. I'm going to ask myself, what can I divide 40 by? Well, I can divide it by 2, and you get 20, right? What can I divide 2 by? I can do 2 again, you get 10. 2 again, you get 5. Now, if you look at all these numbers here, you can't divide these numbers anymore without just getting a 1. All right, you can't split up 2 and 5 anymore. They're prime numbers. So you always want to try and get all prime numbers. Okay, these are called the prime factors of 40. If you multiply 2 times 2 times 2 times 5, it equals 40. So we're going to rewrite our square root, and I'm going to write my 3 2's and my 5. Now they're being multiplied because they're factors. We divided to get them, so they're being multiplied to equal 40. And when you have the factors, the prime factors, you need to look for pairs of the same number. So if you notice, there's a pair of 2's. Now, a pair of 2's are important because what's 2 times 2? Well, it's 4. So this is really just the square root of 4. And the square root of 4 is 2. Because it's a pair, they make a perfect square, and you can take the square root of it. Same thing over here, 2 times 5. Oh, wait, that's not a pair. So no, it's not the same thing. 2 times 5 is 10. 10's not a perfect square. They did not make a perfect square because they're not a pair. So that one, we can't take the square root of. So we're just going to leave it as square root of 10. This is our final answer. 2 times the square root of 10. That's the simplified version of square root of 40.